I think we can start. Are everyone ready? Good. Good morning, everyone, and welcome to the online workshop for the GENTE project. Today it's about boosting scalability and replicability of GENTE solutions. And yeah, I'm looking forward to present you all some outcome of GENTE project. And I will start with an introduction of the project, and then we go with Josephine and Laura with GENTE's key exploitable results, and then we'll have later some results of the demo sites. The demo sites in which one is in Sweden and one in Switzerland, and at the end of today's presentation, we'll have a Q&A and open discussion. So, what is GENTE project? Well, GENTE is an AirNet project aiming to develop solutions for energy communities. The goal is to create a toolkit, and it should foster energy communities by supplying IoT, distributed ledger technology, edge processing, and AI technology. It should also stimulate the creation of new energy communities. And the main goal, as I said, is providing the communities with a toolkit and enforces the creation and participation in such a community. In the project, we have different partners. If I go north to south, it's the University Chalmers, and then we have the University of Applied Arts and Science, the HSLU, and R2M, which is also participating in the project, Prosume. And there was a fifth participant, Raymond, which unfortunately left the project due to difficulties in financing. As I mentioned, we have demo sites, which one is located in Switzerland. It consists of 3 buildings, PV power plant, hydropower plant, battery storage, and heat pumps. And there's a second one in Sweden, and later David will talk more in detail about this demo site. So that's pretty much from my side, and now I'll give the word to Laura and Joe.
To me, I'll take over. Okay, so give me a second. Can you stop sharing and I'll start? Oops. Okay. So, hi everybody. My name is Josephine. I am a researcher here at HSLU. I've been working on the GENTE project almost since its beginning in early 2022. And today, Laura and I are going to talk to you about one of the key exploitable results that has come out of GENTE, which is the toolkit that Romans has been mentioning. First of all, I'm going to give you an overview of the toolkit itself, and then Laura is going to go into its scalability and replicability. The creation of the toolkit for energy communities. And just to give you a bit of an idea of what we're going to go through, I will talk to you about what the toolkit is, who is it for, who's it aimed at, an overview of the format and what methodology we use to create the toolkit, the different stages and sections that exist within it, and then I'll take you through some use cases of how the toolkit could be used and the type of information that it includes. And then finally, I'll talk to you about when is it going to be available and where it will be available. So diving right in, what is it? So the toolkit aims to connect together all of the outcomes and services, results, the research that have been created and achieved throughout the GENTE project. And it hopes to provide this in a user-friendly way that directs anyone who wants to use the toolkit to relevant information as quickly as possible. Its goals are to provide information to energy communities. And this leads to who is it actually for? So basically anyone who's interested in energy communities, local energy communities. That's if you are thinking of joining one and just want to know what they are. If you're thinking of setting one up because you are keen to collaborate with your neighbors on energy production or usage. If you want to participate in one, or if you want to operate one generally. So this is what the toolkit looks like. This is just an overview of it. There's quite a lot more information in here than just this, but I will step you through this, don't worry, it's a lot. In terms of the overview, we took the approach of using the user journey mapping methodology, which is used a lot in user experience design to help visualize the process that someone goes through when they're trying to achieve a goal. So let me take you through each area. First, what you will see across the top are what are called stages. These are the top level actions that we found that people who are interested in energy communities, they go through the different stages or phases. Let me take you through them in more detail. So the first one is motivation. This section aims to provide answers to the question, why would someone participate or set up an energy community? The next one is creation. This one aims to provide information about how to set up a community or how to participate in one as well. Operation, unsurprisingly, this is to give insight into how to operate a community, like what technologies and tools are used and involved. And then inspiration here, it's to provide information about specifically the GENTE demo sites, but also to provide sort of real world examples of energy communities in action. So you get an idea of how they can actually function in reality. So each of these stages is actually broken down into what are called topics. So, and they give structure to the content within each of the stages. So for motivation, the topics focus on what energy communities are for, what they do, like what goals they help fulfill, sort of stakeholders that are involved, what kind of use cases they can be applied to, and how they might contribute now and in the future to the wider energy transition. For creation, the topics are more specific and they focus on like the process involved in setting up a new community and what options exist for setting up those communities, such as what types of business models there are, what organizational models you could apply, regulations that exist in your area, finance models, all that sort of stuff. So the sort of options for setting up, because they are varied and extensive. So then the next one is operation. The topics here focus on how you could simulate an energy community to help define sort of optimal design characteristics and parameters so that it works at its most optimal. They focus also on how production and consumption of energy can be forecast in various ways. Then the tools to help manage energy communities and methods for optimizing the operation of the communities to help maximize on achieving the community's goals. And then the final stage, the final topics within the final stage, focus on the GENTE demo sites. And then also we will be providing resources from other toolkits that have been created from other projects that are focused on energy communities. And this sort of broader, a more extensive set of information that can help a user or potential participant, access information they might want or need. So back to this overview. Next, I want to take you through how the content has been grouped into sections. These sections are a way of grouping the content, and they focus on initially what questions someone might be asking themselves, so someone who's interested in a community. This hopes to provide insight into the types of questions that the content in the toolkit can provide answers to. The next one is key terms. These have been defined to help aid in searching the content within the toolkit for topics of interest. And then the final one, the big chunky one, is resources. So this is where we provide the links to all the relevant resources, information, results, findings, reports, videos.
Hello, Joe. We cannot hear you.
Okay, are we back?
We should be back, yeah. There was
Okay,
an
now,
issue with the
now
mic.
yes, but we missed your audio for like 30 seconds.
I paused because I could tell it was gone. Oh,
Yeah.
again.
Again, this is the HSL one here.
It's not ideal.
So,
Okay, are we back again?
Of course, we could use a master.
Can you hear us again? Yes, okay, good. Okay, so sorry about that. So then what I want to talk to you about now is like how the toolkit can actually be used. So I'll show you a few use cases. Firstly, on the topic of co-design. So here, this is a topic that is not a specific stage topic, but exists in various places throughout the toolkit. So the sort of entry point for this is actually to search the toolkit for a phrase you're interested in, here, the phrase being co-design. And this will take you to the different stages for content there, including what questions might exist or what key terms are there. And then also from there, you can navigate down into the resources section where you will see relevant GENTE content. And then by clicking on that content, you'll be taken out to wherever that resource exists in the content itself. Here, the example is a summary of how part of the co-design process was actually implemented within GENTE in the helping of the creation of a potential new energy community. This was done with our colleagues at the Social Arbeits department. And so for the next use case, I'll talk about the forecast topic, which here you can see is actually one of the top level stage topics. So it's very simple here. What you do is you find the topic in the stage and you follow down the column. So you will see the useful key terms, the types of questions that this content can answer, and then links to various resources. And here the links are the reports that we've written about our forecasting work, research papers that have been published, and also here a GitHub repo for the testing results, just to give you an idea of some of the other types of content that the toolkit includes. Next, optimize. Again, this is a top-level stage topic in the main column, so entry through there. And this is just to give you an example of different forms of content. Here we have a blog post and a video that were created about the algorithms developed for our optimizer tool. And these are all linked in there as well. And so the final use case is actually to give you an idea of the breadth of content we have on some of these topics. And this is for someone who is interested in looking for real-life energy community examples. So for this entry, I've searched the toolkit for the word example, and it has come up with quite a lot of information about our demo sites. We have a huge breadth of information here. We have, the demo websites. We have fact sheets, which you can see here, which provide high-level information about the communities, the type of communities, the numbers of participants, their generation capacity, stuff like that, facts and stats, basically, about our demo sites. David and Roman will take you into more detail in those later in the workshop. So to wrap up from my side, what about the availability? When is it going to be available? So the toolkit is still a work in progress. We are pulling together final results and deliverables from the project. Once it will be available, it will be in the mural board format. That'll be view only, but you'll be able to search it and navigate through it. As well as we'll also provide clickable PDFs so that you can use them offline. If you have workshops you want to do, or if you just prefer to work offline as well. Access information for the toolkit will be sent out to participants of this workshop, our newsletter subscribers, on our LinkedIn profile and on our website when it is available. And so you can see our website here in the bottom of the screen. It's genteproject.com. There you can see our blog posts. You can also sign up to our newsletter if you want to get notified directly or read our newsletter. We have a few coming up. But for now, that's it from me. I'm very happy to take questions at the end when we have our Q&A discussion. But for now, I will hand over to Laura to talk about the replicability and scalability of this toolkit. Thank you very much.
Hi, everyone. I'm Laura Zavala from R2M. And from R2M side, in the GENTE project, we've been working on how to bring the different results and services that we've developed in the GENTE project to the market. So first of all, we started by identifying the key exploitable results from the project. And we put a special focus on the GENTE toolkit that Joe has presented. And then we've been working on defining the possible business model for this GENTE toolkit. And then we conducted a scalability and replicability analysis for the GENTE toolkit, and I will show you the main outcomes of this analysis. So to start with, first of all, we focused on how we can build a business model for the GENTE toolkit. We follow the Canvas methodology, and for that, first of all, we identified the main problem that we wanted to solve with the GENTE toolkit, that was to face the lack of integrated governance tools that we can find on the local energy communities. So the GENTE toolkit could be a toolkit offering governance and flexibility provision management service to different local energy communities, and we would bring it together with some adoption guidelines for people who want to integrate it. We also identified key metrics to know and to relate with the business models, and we generated a unique value proposition saying that the integrated governance toolkit uses IoT, DLT, AI, and edge processing for autonomous resource management and grid flexibility. Also, another important part was identifying the different channels that we could use in order to exploit the GENTE toolkit. For example, through direct sales, partnerships with energy initiatives, case studies, or even through governmental programs. Then another important aspect was to identify all the customer segments related to the GENTE toolkit, in which, of course, we have the local energy community, but also energy network operators, municipalities, or other kind of community organizations could be interested in this GENTE toolkit. And we also identified the early adopters, in which I would remark the different pilots that we have in the project, that there were the first ones to adopt this GENTE toolkit. But we also identified other possible local energy communities that could be interested in this. Of course, the business model development also consider how the cost could be structured and the different revenue streams for this. So once we had in mind the business model that we could apply for the GENTE toolkit, we went to analyze the scalability and replicability potential of the GENTE toolkit. For that, we conducted a multidimensional analysis in which we, first of all, identified the different factors that will influence the scalability potential and the replicability potential. And for that, we choose factors in 4 different categories. In the case of the technical factors, for the scalability, we focus on aspects such as the modularity of the solution, the evolution of that technology, the integration of the software and hardware, or even the existing infrastructure. Then for the replicability side, we focus more on technical aspects such as the standardization capacity, the interoperability, or the interface design, among others. Then for the economical categories, in the case of the scalability, we analyze the potential of economy of scale and profitability of the GENTE toolkit. And for the replicability, we focus more on the business model itself, the economy of scale, and also the market design. And finally, for the regulatory, we focus on the regulatory issues for both scalability and replicability. And in the case of the social aspect, we focus more on analyzing the level of acceptance that this toolkit can have in the different local energy communities. So after conducting this analysis, we reach the following outcomes. First of all, we can say that the GENTE toolkit has a high scalability potential. It can be adapted to local energy communities with different sizes. We can increase the number of users within the energy community, or even consider energy community with more distributed energy sources, and that would suppose a minimal technical barrier. Also, the energy resource management can be done efficiently for these different scales that I'm mentioning. There's an economic viability for long-term sustainability. So all these reasons make it a highly scalable solution. But at the same time, we also identified in this analysis some challenges that we need to keep in mind. First of all, the regulatory environmental. If we have a scenario with limited incentives or policy gaps, this may reduce the financing options when considering scalability. Also, external constraints such as location-dependent regulatory factors. And finally, the size-dependent incentives. Some incentives may vary depending on the size of the local energy community, so that is another important aspect to consider. And then regarding the replicability, in this case, we can say that it has a moderated replicability potential. First of all, it has a strong replication potential within the same country as the ones in which we tested the local energy, the GENTE toolkit during the project. And also, it can have a market-proven profitability in countries with similar regulatory framework, for which we identify Spain, Italy, or Tanzania. And it can be compatible with other financial models, such as, for example, crowdfunding or incentives. But in this case, we also identified challenges regarding the regulatory framework, because we need to take into account the adoption of the GENTE toolkit to the different local policies of the local energy communities in which we are integrating the GENTE toolkit. Then standardization issues, efforts need to align with these regional standards. Finally, regarding the stakeholder acceptance, this is a critical aspect for having a successful adoption into the market. So, taking all this into account, how does the GENTE toolkit create value? We thought about a flexible business model that can be exploited through licensing, consulting, or even modular services. It also presents an adaptable solution to evolving market needs, and a competitive edge based on integrated governance, optimization, and co-creation tools, as Joe has presented. And where can the GENTE toolkit be replicated? It has a high potential in countries with certain policy frameworks, such as the case of Spain, Italy, France, or Netherlands. It could also have new opportunities in other European markets. And existing local energy communities can integrate this GENTE toolkit or some services of the GENTE toolkit with this. And who can benefit from here? Of course, the local energy communities itself, but also municipalities, energy aggregators, or technology providers. And how can these stakeholders contribute to scaling GENTE? By partnering with local energy communities for implementing this GENTE toolkit in new communities, supporting policy alignment and regulatory adoption, or even exploring business opportunities for commercialization. So as a summary, we can say that the GENTE toolkit in which we were working during the project is a scalable and adaptable solution. The collaboration and integration into new local energy communities is key to maximize its impact. So we invite you to explore this option for integrating or scaling to other energy communities. The main challenges and barriers that we identified during our studies in the project were the different policies and incentives efforts adoption. Also, the collaboration is key for successful replication, especially when involving the stakeholders. And finally, standardization and adoption needs for different energy frameworks. So these were our main outcomes from this replicability and scalability analysis. Then if you have any questions, we can go for that at the end. And now I will leave the floor to my colleagues that will show some results about the HSV Living Lab and Quasar pilots.
Thank you a lot, Laura. I think it's my part right now, so I'll switch to presentation. So,
The presentation,
yeah.
if you go back to the presentation,
Yeah.
there you go.
Yeah. Okay, thanks. So I will first start with the demo site in Switzerland, and then David will talk about the Sweden demo site. And here, at the first glance, you see the architecture, the system architecture. The goal is not that you can read everything, but I just want to give you an overview that we have mainly 3 parts. And the first part we have at the demo site is we need to get data. And this one we do with a logging part. We do measure most of the energy and power values from the demo sites. And we also measure or get the weather predictions and the actual weather data from Meteo Survey. And with this, we will transfer the data into databases, which are also fed with other data from Forecaster. We have a Forecaster algorithm that forecasts the PV, the photovoltaic yield, and also the energy usage of the buildings. And with all this data, we run an optimizer, and this optimizer controls the set points of the batteries, and also controls the heat pumps, switching them on or off, depending on the energy need or the temperature need of the tenants, or depending on the schedule we have in the algorithm. And these parts, they're all separate and they're containerized, so it's quite easy to have them portable to deploy on a Linux system or Windows system. You can have them in the cloud or on premise. Here you see an example of the data collection. It's actually quite a lot of data we collect And yeah, an example is all the smart meters. We have the heat pump, the EV charging stations, of course, the PV, battery storage, hydropower plant, and so on. So what are we doing with all this data? We have two forecasters. One is for the electric load, which you see here on the picture. We have the actual load, which is depicted in blue. And then we have the prediction, which will be, or which is in orange. And then we have a so-called benchmark. That's data we compare the forecaster. And this one is just the day, the data from the day before. So we compare it with this data. And the forecaster is based on the LSTM model. And if we calculate from start of July to mid-September, we get here the results on the bottom. You see we have the load model has this loss about 22%, and if we compare it to the benchmark, it's much higher. That shows that the forecaster works pretty well. And besides the PV, we also forecast the electric load, and you see here the same. We have the target, which is like the actual data, and we have the prediction. And you can see here some interesting spikes, which the model can predict. For example, in the morning, this would be charging the domestic hot water to a certain temperature range. And then we have one in the morning where people using electricity, and one is in the later afternoon, and then when they come home and do cooking, and later also when they do charge the electric vehicle. And the third part I showed, this is the optimizer, and the optimizer actually controls the electric batteries, the heat pumps, all the flexibilities. And the optimizer can be set for 3 objectives, so 3 goals. The first one is you can set to reduce the CO2 emissions of the community. So if you set this as a goal, you're able to reduce the CO2 by 24%. And this will be for an EC in Spain. Set it to the goal to self-consumption. You can increase your autarky from 62% to 75%. That's a 13% increase, and 13 related to 62 is about 20% better performance we have. And a third objective will be the load peak reduction. So you can reduce the power from, or the power peaks from the grid, and also reduce the power fed into the grid. And you can see it's a 19 or 20% reduction, and the export reduction will be about a little bit more than 130%. So that's pretty much from my side, from the Swiss demo side. So I'll hand over to David to show you results from Sweden.
Just stop sharing. Yeah. So David can share.
And it says that I'm not allowed to share my screen now.
Consuelo, can you add David as a co-host, please?
Sorry, again?
Can you add David as a co-host?
1 second.
Thank you. Actually, we might be able to do that. Remember, I don't know.
Yeah, now it works.
Thank you.
So, you see my screen now?
Yes.
Yeah.
All right, good. So I will present the demonstration and activities that we have done in HSP Living Lab here in Sweden, in Gothenburg. So this work is mainly conducted by Alexander, Reza, Mariam, and Tuan. And I have supported a little bit, but I shouldn't take all the credits. But yeah, I will go through a little bit what is HSP Living Lab, a bit on the demonstration case, IoT sets up, and a bit on the results. So HSP Living Lab is a multi-family house located at the Chalmers campus. They have a lot of sensors and metering equipment, but also renewable production from solar PVs. They have a battery energy storage. They have heat pump and district heating connections. You can choose if you want to use heat pumps or district heating. We also have hot water storage tanks, an EV charging station, some controllable devices like dishwashers and laundry and tumble dryers that we have tested and demonstrated. So what we have done in the project is very similar to HSLU. We have developed different forecasting algorithms. We have developed this energy management system for batteries, heat pumps, thermal energy storage, and building thermal inertia. Then we have investigated the possibility to provide grid support from these buildings, but also to simulate a virtual energy community using the energy management system. So similar to HSLU, we also have developed the models in Python, and we're running them on a Windows server as we collect data from different sources. We have load data for the building. We have spot market price data. We have weather data from a company called Rebase that provides both historical and real-time data forecasts or weather forecasts. So we're putting those measurements into a database, and then we're using it to train the forecasting model, and the forecasts are then used in the optimization where we collect the set points and objective values from the optimization, but we also send the set points to the different device from the optimizer. So control the heat pumps or the battery storage. When it comes to the load and PV forecasting, we have also used LSTM, but we also tested a bit different algorithm to do the load and PV forecast. So both convoluted LSTM and GRU. And then we tried to map or make this correlation test to find the best features. And of course, the solar radiation is the most with highest correlation, but also the humidity have a quite high correlation. So we're using that in the forecast later on. So this is one test for a day in July, I think, where you have the actual PV production and the predicted demand. So compared to the figure that Roman showed, here we are doing it more hourly forecast, so we don't get these smaller variations. So it's more average. So it's a little bit easier to make this forecast compared to the minute by minute forecast. But then also for the electricity load, we have very good accuracy of the forecast. When we look at the energy management system, so as I said, we are using it to schedule the energy storage and the heat pumps of the building, and then also to provide flexibility to the DSO. So when we do that, we reschedule the, so without the flexibility provision, then we are scheduling the building or the energy demand based on the cost. But when we provide the flexibility, we may increase the energy cost, but we will also get more income from the flexibility market or the flexibility provision. So here we have a case where we're using the battery charging and discharging the orange bars here. And then we have the heat pump as yellow. When we start the flex market to provide flexibility, then we are rescheduling how we're utilizing the battery to provide the flexibility. And the amount of flexibility that we provide depends on the price that the DSO will pay to the customer. So we have used different price to see how much flexibility we provide, and we can see that in this figure. And the higher price, the higher income we will get from the DSO. But at the same time, we will increase the cost for the energy scheduling. So in this case, where we're using the highest spot price for this specific day, we see that we are providing more flexibility for the DSO. So here we started the flex market between 12 to 20 for this day. Another test that we did in the building was related to the thermal inertia of the building. So we tried to reduce the set for the floor heating system. Originally it was 40 degrees, and then we reduced it to 25. And by doing that, we are stopping the heat production. And we see that the temperature is decreasing slightly during the test. And then when we increase it again, then we have an increase in the indoor temperature. But it's also important to see that this is very, very small deviations. We did the test for 7 hours here, and we only had a reduction in temperature of 0.5 degrees. So we have quite massive thermal capacity in the building that we can utilize to reduce the demand of the system if we have a heat pump. Another case study that we did was to simulate the local energy community. So here we have the HSB Living Lab, and we have another building where we could also simulate them as a local energy community or not a local energy community. And then we'll use the energy management system to schedule the resources. And it's hard to see here, but based on the simulation, we get a reduction in annual energy cost. We reduce the peak load slightly for these two buildings. We increase the self-consumption and also the self-sufficiency within the building when simulating this. But this self-sufficiency is very low because we have had not very large PVs on the building. All right. That was everything I have to say. If you have any question, we can take them now. Discussions.
Yeah. Thank you a lot, David. So I think we can move to the Q&A. I thank you all for participating and also for presenting and asking questions and for a discussion. Yeah, I think we can close today's workshop.